Okay, welcome back to the fourth part of logarithm, exponential and logarithmic equations. In this part, we will deal with exponential and logarithmic equations, and we will solve some really good problems here. I have 8 problems that are waiting for us. So let's start. Yes. If we have an equation like this, logarithm of f x to the base of a is equal to logarithm of gx to the base of a, since the bases are equal, then the inside of the logarithms also must be equal to each other. If this condition is met, then fx is definitely equal to gx, but you don't forget to check that for both of fx and gx must be greater than 0. This is the equation for logarithmic functions, and also don't forget that when converting logarithmic function to exponential function, we are using this logarithm of fx to the base of a is equal to b. Then if this is equal to b, then fx is equal to a to the power of b. If you remembered this property, then you should remember that we had moved a under b, then fx would be equal to a to the power of b. So I'm sure that you will understand it better with this question. So let's start solving the first question. Example 1. Find the value of x. We are given an equation logarithm of 2x plus 3 to the base of 2 minus logarithm of 3x plus 1 to the base of 2 is equal to 0. So if I just move this expression to the other side of the equation, I get logarithm of 2x plus 3 to the base of 2 is equal to logarithm of 3x plus 1 to the base of 2. And the bases are equal. They are both logarithmic function, and the bases are equal. They are 2. That's why the inside of the logarithmic function also must be equal to each other. Then we get 2x plus 3 is equal to 3x plus 1. And if you move x to this side and 1 to this side, we get x is equal to 2. And we should check if inside of the logarithmic functions are positive. If we place 2 inside of the x, here we get 2 times 2 plus 3, which is 7, and here is also 7. 7 is greater than 0, so x is 2 is okay for us, and we get x is equal to 2. Okay, example 2. Find the solution set of the given equation. We are given logarithm of x to the base of 7 plus logarithm of x plus 6 to the base of 7 is equal to 1. And did you realize that both of their bases are 7 and there's a plus between them? So I can just rewrite this as logarithm of x times x plus 6. Since they are addition, I can rewrite them as multiplication inside of one logarithmic function. This is equal to 1. And if I move 7 under 1, I get that x times x plus 1 is equal to 7 to the power of 1. And I write x times x plus 1 is as x squared times 6x. And this is equal to 7 to the power of 1, which is 7. Okay, so if I want to solve this, I get x squared plus 6x minus 7 is equal to 0. And I can just factorize this as x and 7 and 1. And I put a minus in front of 1, so their product is minus 7, their sum is plus 6. So this expression is actually equal to x plus 7 times x minus 1 is equal to 0. That's why x is either minus 7 or it is equal to 1. But we should know that the inside of the logarithmic function cannot be negative. That's why if I place minus 7 here, then I get logarithm of minus 7 to the base of 7, and inside of the logarithmic function cannot be minus. That's why x cannot be equal to minus 7, but 1 is okay, because if I put 1 here, it is okay, and if I put 1 here, it's also okay. The inside of the logarithmic functions for both of the logarithmic functions becomes positive. That's why the solution set is only 1. Okay, Example 3. Find the value of x. We are given an equation, logarithm of x plus 4 to the base of 7 minus logarithm of x plus 2 to the base of 7 is equal to 2 times logarithm of 3 to the base of 7 minus 1. I can rewrite here as logarithm of x plus 4 over x plus 2. Why is it? Because there is a subtraction between them, and I can rewrite them as a division inside of one logarithm and logarithmic function. And here I will make some changes to this place. 2 times logarithm of 3 to the power of 7. I will move 2 here as an exponent of 3. It will become logarithm of 7, logarithm of 3 to the power of 2 to the base of 7. And here I have minus 1, and this minus 1 can be rewritten as logarithm of 7 to the base of 7. Since logarithm of 7 to the base of 7 is 1, I can rewrite this like this. I can rewrite it like this, and this will be equal to, if I write it only one logarithmic function, logarithm of, this is 9. And since there is a subtraction here, I can write over 7 to the base of 7. So this expression is equal to logarithm of 9 over 7 to the base of 7. Okay, this is equal to this expression. So their bases are both 7 and 7. That's why inside of the logarithmic functions must be equal. And I get that x plus 4 over x plus 2 is equal to 9 over 7. And if I get if I multiply here by 7, and if I multiply by here by x plus 2, I get that 7 times x plus 4 is equal to 9 times x plus 2. 7x plus 28 is equal to 9x plus 18. And if I move 7x here, I get 2x. And if I move 18 here, I get 10. 2x is equal to 10. That's why x is equal to 5. And I don't, yes, let's check the inside of the logarithmic functions. If I put 5 instead of here, I get 9. Here I get 7. That's why there is nothing wrong about this one. So x is 7. Let's move on to the next page. Example 4. X and y are real numbers different from 0. It is given that 3 to the power of x is equal to 15 to the power of y. Since they are different from 0, I cannot just say that this is 0, this is 0, and 1 is equal to 1. That's why I need to use a logarithm. Then what is the value of the expression below? X minus y over x plus 1, x plus y. Now here I will leave x alone here. It will become easier to solve it. And to leave x alone, I'll just take the logarithm of each side to the base of 3. If I do that, I get logarithm of 3 to the power of x to the base of 3 is equal to logarithm of 15 to the power of y to the base of 3. And here logarithm of 3 to the power of 3 is just 1. If I move x here, I am only left with x. X is equal to logarithm of 15 to the power of y to the base of 3. And if I move y here, I get y times logarithm of 15 to the power of 3. But I will not leave it like this. I will change, yes, I will change this expression. Logarithm of 15 to the base of 3 can be rewritten as logarithm of 5 logarithm of 5 times 3 to the power of 3 to the base of 3. What I mean is that x is equal to y times logarithm of 5 times 3. 15 is equal to 5 times 3. And this is also equal to y times logarithm of 5 to the base of 3 plus logarithm of 3 to the base of 3. Since this is a multiplication, I can separate it by using an addition in two different logarithmic functions, and that's why x is equal to y times, this is logarithm 5 to the base of 3 plus logarithm 3 to the base of logarithm of 3 to the base of 3 is just 1. And if I add if I just rewrite this, I can say that x is equal to y times logarithm of 5 to the base of 3 plus y. I found that x is equal to this expression, and wherever I see x, I am just gonna write this expression here. That's why x minus y becomes y times logarithm of 5 to the base of 3 plus y, and here I have also minus y over x. There is an x, that's why I'm writing this, y times logarithm of 5 to the base of 3 plus y, and also I have a y here. And plus y and minus y just cancel each other. I am left with y times logarithm of 5 to the base of 3 over, here I have y times logarithm of 5 to the base of 3 plus 2y. I have 2y here. And if I take it into common parentheses for y here, the numerator is logarithm of 5 to the base of 3. And the denominator is, if I take it in the common parentheses, y times logarithm of 5 to the base of 3 plus 2. Okay, these y's will cancel each other, and I'm only left with logarithm of 5 to the base of 3 over logarithm of 5 to the base of 3 plus 2. But I will just write, I will not just write plus 2, I will write logarithm of 5 to the base of 3 plus logarithm of 9 to the base of 3. These are equal to each other because 9 is 3 to the power of 2. This 2 becomes logarithm of 9 to the base of 3. And this expression becomes equal to logarithm of 5 to the base of 3 over, since there is an addition, I can rewrite this logarithm of 45. Why? Because 5 times 9 is 45 to the base of 3, and their bases are equal. Since their bases are both 3, I can rewrite it as logarithm of 5 to the base of 45. Yes, this is my answer. And next one, example 5. If the root of the given equation is x is equal to 2, then find the value of a. We are given the root, we are given the value of x, but we are asked the value of a. So since the root of the equation satisfies the equation, that's why I can just write 2 instead of x, and logarithm of here becomes 2a minus 2 to the base of 2 is equal to logarithm of, now here I have 4, but here I have 2. Since this is an equation, I want to make them both equal to each other, and I can rewrite 4 as 2 square. And here, wherever I see x, I can write 2. That's why 2 times 2 is 4. Here becomes 4 minus a. This is equal to each other, but I cannot say 2a minus 2 is equal to 4 minus a because their bases are not equal. Here the base is 2, here the base is 4. That's why I will now equalize the bases. How can I do that? I can get rid of this 2. Logarithm of 2a minus 2 to the base of 2 is equal to, this 2 comes here as 1 over 2, it's reciprocal, times logarithm of 4 minus a to the power of 2. And if this 1 over 2 comes here as a coefficient of 2, it will become 2 times logarithm of 2a minus 2 to the power of 2. There are so many 2's in this equation. Logarithm of 4 minus a to the base of 2. So here they are both 2, but there's still a 2 here. If I want to get rid of this 2, I can just move it here as a power, as an exponent. So I get logarithm of 2a minus 2 square, this 2 became a square, to the base of 2 is equal to logarithm of 4 minus a to the base of 2. Now the bases are finally equal, they are both 2. That's why inside of the functions must be equal to each other. I get that 2a minus 2 square is equal to 4 minus a. And if I do if I find the square of 2a minus 2, I get 4a squared minus 8a plus 4 is equal to 4 minus a. This 4 and this 4 cancel each other. If I move 8a here, I get, let's write here, 4a squared. I am gonna add plus a to each of the sides. Here becomes minus 7a is equal to 0. And if I factor this, I get a times 4a minus 7 is equal to 0. There are two options here. A is gonna be either 0 or 4a minus 7 is going to be 0. 4a is going to be 7 and a is going to be 7 over 4. Now, if I write a in here, will the inside of the function be positive? If I write if I write 0 instead of a here, I get 2 times 0, which is 0, minus 2. Inside of the function will become minus 2, and inside of the logarithmic function cannot be equal to 0. That's why a cannot be equal to 0. And if I put 7 over 4 instead of the logarithmic function here, 4 minus 7 over 4, which is equal to 1.75, it will become positive, and here will become 7 over 2, which is 3.5. 3.5 minus 2 is 1.5. 1.5 is positive. That's why 7 over 4 is okay. And the answer is 7 over 4. Okay. Example 6. Find the value of x. We are given 2 to the power of x plus 1 is equal to 3 to the power of x. And to find the value of x, I want to leave x alone, and it is easier if I take the logarithm of each side to the base of 3, because if I take logarithm of each side to the base of 3, then I will leave with x in here. I will have logarithm of 2 to the power of x plus 1 to the base of 3 is equal to logarithm of 3 to the power of x to the base of 3. Now, if I move x plus 1 in front of the logarithmic function as a coefficient, I get x plus 1 times logarithm of 2 to the base of 3 is equal to, and if I move x here, I get x, and logarithm of 3 to the base of 3 is just 1. That's why I'm left with x here. And I have x plus 1 times logarithm of 2 to the base of 3 on the left side. That's why I can just rewrite it as x times logarithm of 2 to the base of 3 plus logarithm of 2 to the base of 3, and this is equal to x. And since I want to find the x, I will collect all of the x in one side and then leave x alone. That's why if I move this term to here, I get logarithm of 2 to the base of 3 is equal to x minus, I subtracted this term from each of the sides, x minus x times logarithm of 2 to the base of 3. And if I take it into common parentheses, I get that logarithm of 2 to the base of 3 is equal to x times 1 minus logarithm of 2 to the base of 3. Okay, now if I want to leave x alone, I can just divide each side by this term, and I get that x is equal to logarithm of 2 to the base of 3 over 1 minus logarithm of 2 to the base of 3. But I will not leave it like this. I will simplify it. So here I have 1 minus logarithm of 2 to the base of 3. I can rewrite this one as x is equal to logarithm of 2 to the base of 3. I can rewrite this one as logarithm of, since the base is 3, I can rewrite this logarithm of 3 to the base of 3 minus logarithm of 2 to the base of 3. And because of that minus, I will have logarithm of 2 to the base of 3 over logarithm of, because of that minus, I will have 3 over 2 to the base of 3. And their bases are equal, their bases are both 3. That's why I can just write that it is equal to logarithm of 2 to the base of 3 over 2. This is my answer. X is equal to logarithm of 2 to the base of 3 over 2. And the last page, we are there are only 2 questions left. Let's take a look at example 7. Example 7, find the value of a. We are given a right triangle, and the sides of all of the sides of the right triangle. Here is square root of 6, here is logarithm of a to the base of 2, and logarithm of 2a to the base of 2. Since it's a right triangle, I can just use the Pythagorean theorem, and I can say that the square of this term and the square of this term, their sum is equal to the square of this term. Okay, so let's write it. The square root of 6 plus the square of logarithm of a to the base of 2 is equal to the square of this term. Okay, before going any forward, I will do something. I will do some changes with this term because it will be much more easier. Wait, let's just write it in here and do our changes above. The square root of 7 plus the square root of a to the base of 2 is equal to the square of logarithm of 2a to the base of 2. Okay, now I will simplify logarithm of 2a to the base of 2. Logarithm of 2a to the base of 2. Since this is 2 times a, I can separate it into 2 separate logarithmic functions. It will become logarithm of 2 to the base of 2 plus logarithm of a to the base of 2. Since they are in the multiplication form, I can separate it as an addition. Logarithm of 2 to the base of 2 plus logarithm of a to the base of 2. And logarithm of 2 to the base of 2 is equal to just 1 plus logarithm of a to the base of 2. This is equal to this one. And I will use substitution method here. It will be much more easier. I will say that let's give a ladder to logarithm of a to the base of 2. Why? Because if I write this term instead of here, I get logarithm of a to the base of 2 here and also here. So I can just use substitution method. Let's say logarithm of a to the base of 2 is equal to d. Let's use d. And I can rewrite this as square root of 6 plus, since I have equalized it to d, I can write d square here, and here I have 1 plus d. That's why this is the square of 1 plus d. And let's get rid of the square. Square root of 6 is just 6 plus d square, and here I have 1 square of 1, which is 1, plus 2d plus d square, and the d squares will just cancel each other, and I am left with 6 is equal to 1 plus 2d, and that's why 2d is equal to 5 and d is equal to 5 over 2. But 5 over 2 is not our answer. We are asked the value of a. And what did we say about d? D is equal to 5 over 2 and d is equal to logarithm of 6 to the base of 2. That's why logarithm of a to the base of 2 is equal to 5 over 2. Now if I want to leave a alone here, I am moving this 2 in under the 5 over 2 as a base, and a will be equal to 2 to the power of 5 over 2. And what is this equal to? It is equal to 2 to the power of 5, and there's a square root around it, and it is equal to square root of 32, which is 4 times square root of 2. This is the value of a, our answer. And the last question, it is a question from the 2020 IET exam. I wanted to include it because it's a really good question. When a stick is divided into 4 equal parts, the length of each part becomes logarithm of x to the base of 5 units. When it is divided into 10 equal parts, the length of each part becomes logarithm of x squared over 25 to the base of 5 units. what is the total length of the stick? First, I will write an equation. And if it is divided into 4 equal parts, this is the length of each part. That's why the total length of the stick is 4 times logarithm of x to the base of 5. This is the full length of the stick. And if I divide it into 10 equal parts, then the length of each part becomes logarithm of x squared over 25 to the base of 5. This is the total length of the stick. That's why these are equal. And since I have written my equation, now it is much more easier to solve. We are just going to solve a logarithmic equation. And this 10 and this 4 will cancel. Here we are left with 2. Here we are left with 5. And 2 times logarithm of x to the power of 5 is equal to 5 times. Now I will rewrite this as, since this is a division, I can separate it. Logarithm of x squared to the base of 5 minus, I am using minus because it's a division, logarithm of 25 to the base of 5. And 2 times logarithm of x to the base of 5 is equal to 5 times, let's just write this 2 in front of the logarithmic function as a coefficient. It will become 2 times logarithm of x to the base of 2. Now we have logarithm of x to the base of 2 on each side. It will be much more easier, trust me. Minus, this is a logarithm of 25 to the base of 5. This is just equal to 2 because 25 is 5 squared. Since it is 5 squared, it is just equal to 2. And 2 times logarithm of x to the base of 5 is equal to, I will multiply these terms, 5 times 2 times logarithm of x to the base of 5 is 10 times logarithm of x to the base of 5 minus 5 times 2 is 10. And if I move this here and move 10 here, I get 10 is equal to 10 minus 2 is 8. 8 times logarithm of x to the base of 5. That's why logarithm of x to the base of 5 is equal to 10 over 8 or 5 over 4. I found logarithm of x to the base of 5 as 5 over 4, and I am not asked x, I am asked the total length of the stick. And at first, what did we say about total length of the stick? We said that the total length of the stick is 4 times logarithm of x to the base of 5. That's why, since the total length is equal to 4 times logarithm of x to the base of 5, we have found logarithm of x to the base of 5 as 5 over 4. That will become 4 times 5 over 4, and the 4's will just cancel each other, and length is 5 units. And this is the end of our video, end of part 4. In this part we have solved many questions about logarithmic and exponential equations. In the next part we will deal with exponential and logarithmic inequalities, not equations but inequalities. So see you in part 5.